Good morning and welcome all to today's webinar. I'm Aranzazu Galán, part of the editorial board of BuildUp. BuildUp is Europe's largest international portal for energy efficiency and renewable energy in buildings. It is a unique community that provides the opportunity to discuss, contribute, and collaborate with other experts in this field. BuildUp aims to bring together stakeholders working in the building sector to reap collective intelligence about energy reduction by encouraging knowledge change. Our editorial work is organized around the topic of the month, which allows us to go deeper into a specific theme. Each month, several items are produced as overview and technical articles and infographics, but not exclusively. BuildUp also offers the opportunity to host webinars on all the topics related to energy efficiency. More recently, BuildUp has opened the opportunity to distinguished experts in the field to share their knowledge in front of our cameras in the BuildUp Expert Talks. BuildUp portal shares daily the most relevant events in the field of energy efficiency and renewable energy, but also participates actively in many European events around the year as EPB Center and RIBA conferences, Horizon 2020, Interreg, and cost action events, Covenant of Mayors, and much more, with the aim of further disseminating the results and helping to create high-quality media content. BuildUp content is updated daily, reaching around 120 items each month. But BuildUp is not only us. BuildUp is a community, and we invite you to be part of it. By becoming a member, you can contribute uploading your own content and promoting your own news, events, or publications. BuildUp will help you to reach a broader audience through our social media channels and newsletter. It is a pleasure to host today's webinar entitled The Plug-n-Harvest Solution Enabling Smart Energy Renovations for Different Building Cases, which is organized by the Plug-n-Harvest project. In today's agenda, Dr. Iakobos Michailidis, electrical engineer and technical manager of Plug-n-Harvest at Center of Research and Technology Hellas, CERT, will present the plug-and-play passive and active multimodal energy harvesting systems, circular economy by design with high replicability for self-sufficient districts near zero buildings. Tony Gerena, business and energy analyst at IWASOL, will present the circular economy aspects of the design. Neil Juvanteni, industrial engineer at Housing Agency of Catalonia, will present the pilot case 3, that is the Sant Quirze residential building in Catalonia, in Spain. The final presentation will be from Dr. Nikolaos Margaritis, mechanical engineer and project manager at Center for Research and Technology Hellas. He will present the pilot case 4, that is the RWM Grevena tertiary building in Greece. The audience is welcome to send us questions through the platform. These questions will be answered at the end of the presentations in a session moderated by Susanna Prochaskova, Innovation Architect at Pitch Architects. I leave the floor now to our first speaker, Dr. Iakobos Michailidis, who will present the Plug-n-Harvest project. Thank you very much and enjoy.
Hi, I guess you can hear me. So I would like also to take the opportunity here to thank also BuildUp people for giving us the opportunity to present the project and its results. So my name is Iakobos Michailidis. I'm a postdoctoral research associate in the Information Technologies Institute, which is under the Center for Research and Technology Hellas. And CERT is the coordinator of the project, and I'm mainly involved in the technical management of the project itself. I will do the introductory part to present the general idea of the project, and then we will move on with my colleagues and the next speakers. So, as a general overview, Plug-n-Harvest is a Horizon 2020 project funded under Energy Efficiency in Buildings 07-2017 topic. It started actually in September 2017. It went through COVID and eventually managed to, let's say, complete and finish in November 2022. actually quite a few weeks ago. The consortium is consisted by 14 partners coming from 4 EU countries. Now, just to also take this opportunity, and I mean, feel free for the audience, feel free to follow up the project's outcomes and its results, especially as we are now, let's say, delivering the final results, which are actually summarizing the achievements of the project through our social media channels and the project website, which you may find here as well. Now, moving on to the idea behind the project. The main idea of the project lies behind exploiting empty areas of the project. So the idea was to exploit empty surrounding areas, especially if you consider high-rise buildings. So we have, let's say, less roof area to exploit, while we have more surrounding areas to exploit for deploying, let's say, technologies for the building. So the idea is it's a facade which is vertically deployable, and it can host, and we can deploy through these facade technologies as well as building technologies and energy technologies, and as well as we can couple them with AIs to maximize their operational potential. So this vertical approach allows us also to enable apartment-specific renovations and allows for different insulation technologies and strategies to be deployed according to the different occupants' energy and aesthetic needs. So the facade is quite modular, so we can deploy different technologies like PVs or insulations at different, let's say, in different elements or components of the facade. The main objective now of the project, moving on from the idea, is to develop a modular smart facade system that can be easily adapted to the different building cases and requirements to move them one step closer to energy neutrality. The facade system should be able to ensure low installation costs. These are the goals of the project. Circularity through reusable parts and components and elements. Energy harvesting through PVs, as an example, and structural resiliency through innovative aluminum profiles, which are able to withstand much heavier technology loads rather than conventional ones, which may host only, for example, panels. Moreover, since conventional insulation here and technology infrastructure elements are not capable to guarantee energy efficiency on their own, smart ICT solutions are necessary to manage controllable elements appropriately. So what Plug-n-Harvest tries to do is I mean, the first pillar is the facades, the modular facade, and the second pillar is the intelligence part, the AI part, which Plug-n-Harvest tries to marry these two in order to provide the capacity to the building and exploit the capacity that is installed on the building through AI. Just to explain it better, if I may. Now, the quantified goals. Sorry. The quantified goals of the project. It's to ensure installation costs to be by 20% less than conventional energy retrofitting solutions when in production scale, of course, not as a prototype. Reduce energy bills up to 50%, maximize exploitation of locally harvested energy up to 80%, and of course, as always, ensure the acceptance of end users by over 90%. As implied already, the Plug-n-Harvest solution is consisted by two main pillars. As mentioned, the facade and the digitalized part, the AI part. So the first part, the facade part, let's say, it has been designed in order to be able to host detachable aluminum panels that can be easily configured to integrate both passive insulation materials, like stone wool, for example, as well as active technology materials and elements for energy harvesting and demand reduction, like PV panels or even HVACs or I don't know, heat recovery systems, for example, as an idea. About the ICT part now, the second, let's say, pillar of the project, just to move on with the presentation. It is consistent. It's comprised by an ecosystem of different tools. So it's on your right-hand side. Let's say you may consider the building itself, coupled, let's say, with a facade, the ADB facade. Now starts the digital part. So we have the sensors and the actuators that are that allow us to control the facade together with the other, let's say, the available loads, the existing loads of the building, of the microgrid. So we have the automation connectivity, the common protocols and the APIs, the BMS server, which ensures also communication security through CPADE encryption. We have we consider a data model which is based on FireWire NGSI, which is an open protocol and well standardized in the IoT community. We have pre-processing algorithms for data curation and filtering. Then we move on with to flexibility forecasting at the district scale, and eventually there is the heart, the core ingredient of the ICT ecosystem, which is the energy management tool, as we call it, intelligent management and control system, which is responsible to take into account the forecasting of the flexibility as well as the data that have been curated in order to provide, to generate optimized control decisions for and actuation signals, let's say, for the building and the microgrid controllable loads to close the loop of the control. Now, to conclude and leave the floor to the next speakers, Plug-n-Harvest includes real-life experimenting with 2 pre-pilot sites. Of course, one in Thessaloniki, these are pre-pilots, one in Thessaloniki, Greece, and another one in Cardiff, Wales. And, the one is in CERT here, and the other one is Cardiff University in Wales. And 4 real-life demonstration sites, large-scale ones. 2 of them are residential, a multi-family building in St. Quirze, Barcelona, Spain, and 2 single-family houses in Cardiff, Wales. While the other 2 are tertiary buildings, office buildings, one in the region of Western Macedonia, RWM, in Greece, in Grevena, Greece. And the last one is in RWTH Aachen University campus. It's a building there, an office building in Germany. And today we will focus, just to also present the largest, let's say, pilot cases. We will focus on the outcomes from the Plug-n-Harvest solution implementation in 2 large pilot cases, the one in Spain and the one in Greece. However, before that, let's say I give the floor to my colleague, Tony Herena from Aiguazol, who will present the circularity aspects that we also considered for the project designs and the solutions. That's all from my side.
Thank you very much, Dr. Michalaidis. Thank you for this very interesting insight of the Plug-n-Harvest project state of the art. And as you were very well saying, we pass to Tony Herena, as we said before, business and energy analyst as Aiguazol, who is going to give us an insight of the circular economy aspects of the design. Thank you.
Thank you. So I am Tony Herena. I am leading the building sustainability department here in Aiguazol. And Aiguazol is an energy and low impact consultancy, little cooperative in Spain. And our role in the project was the leading of the work package 1 related with the KPI and end user requirements, and work package 5 that was a little bit strange work package 5 because it includes also aspects like circularity, like the development of a circular methodology for assessment, and also a business model or circular business model, as well as LCA and LCC duties. So the main goals in this circularity aspect for the Plug-n-Harvest was to develop a facade, a modular facade that could allow a massive replicability of these solutions according to every market condition, and to enhance or to ensure payback periods less than 10 years by considering the complete solution as physical and financial assets. Sorry, but I don't know if I have lost the. Oh, okay, it's a little bit delayed. I think it's very low, my connection or the. Sorry, but I'm trying to go to the previous. I don't know why it's passing the slides. I'm not doing it. Okay, so I will go on. The main topics of this Plug-n-Harvest for us was to the development of a modular
Hello?
Tony, I think we have lost your connection.
Yeah. Tony, if you like to help your connection as well, just disable your camera at least just to save some bandwidth from your side.
Your connection is a little bit weak, and we have not hear you. Do you hear us? Do you hear us, Tony? If not, we can, if you are having any troubles, we can pass to Neil. Exactly. Neil, Maria, could you pass the controls to Neil while Tony search a better place? Yes, hello. Okay, so we're gonna pass momentaneously to Neil Juvanteni from the housing agency in Catalonia, in Spain. He's gonna present us the first pilot case in Sant Quirze. It's a residential building based in Catalonia. Thank you very much, Neil. The floor is yours.
Okay, good morning, everyone. Thank you very much for the introduction, and thank you also to all the build-up community for holding this webinar and let us to present our project. And thank you also to all the listeners that are here today. Okay, as already said, my name is Neil, and I'm here representing the housing agency of Catalonia. We are a public company dedicated basically to manage a big amount of public buildings property of the government of Catalonia, and especially that ones dedicated to social housing. So one of those buildings was selected to become a pilot case for the Plug-n-Harvest project. And in this presentation, I will present you the building, explain and show the renovation that we have done through the Plug-n-Harvest, and finally show also some results. Okay, so let's start with a brief description of the building in its initial state. It is located in Sant Quirze, which is a small city in the province of Barcelona. It is a residential building from the year 2003 dedicated to social housing, and it is formed by 3 blocks organized in a U shape, but the only one affected by the Plug-n-Harvest renovation is the block A, which is the one in the middle. The principal axis of the block A is south-north oriented and has 4 levels. In the ground floor there is a premises, and then in the other floors we have 2 dwellings per floor, which make a total of 6 dwellings in the block. And the Plug-n-Harvest renovations is focused on the south facade of the block A, which is the one marked in green here in the picture. and has a surface of 101 square meters. On its initial state, this facade was a Naturvex ventilated facade with low isolation and fiber cement boards as cladding. One of the reasons for selecting this building was that it presented a lot of pathologies, especially in that ventilated facade. As you can see in the pictures, for example, the fiber cement boards were broken and falling, especially in the corners. And also there were a lot of thermal breaches between the isolation plates or between the window and the main wall, as you can see. And so the Plug-n-Harvest solution will help to solve all of these pathologies. Okay, let's see. One moment, because the slides are passing without. Okay, this one. The Plug-n-Harvest solution applied in the renovation is what we call the ADB facade panels. ADB means Adaptable Dynamic Building Envelope, and these are at the end prefabricated modular facade panels based on an innovative aluminum profile, which has been designed especially for that project. Here you can see the drawing of the design of the profile in section, and then the real one manufactured and extruded at the desired length. Finally, and from that profiles, we create or we construct what is the frame or the structure of the panels, and from that we can add several active or passive technologies to the profile in order to get the final result of the profile. In the case of St. Quirze, we have incorporated several passive and active technologies. In this case, we have 10 centimeters of thermal insulation of mineral wall. We have also installed new high-performance windows, which include aluminum frame with thermal bridge break, double glassed windows with argon gas gap in the middle, and shutters of anodized aluminum. Then we have also incorporated photovoltaic panels, which are tailored ones. And finally, in the areas where there are no windows and there are no PVs, we have installed aluminum cladding. Okay, I'm going to pass very fast through this slide because I don't have time to explain this in detail, but just for you to know, a sample of 2 ADB panels was subjected to an official laboratory test in a certified laboratory. Basically, in order to maturate the technology enough and be sure that it was possible to install the technology, let's say, in a real building and not only in the laboratory. And well, all the results were very positive, so we went ahead with the installation in the site. In St. Quirze, we have installed a total amount of 21 ADB facade panels. These were divided in 3 rows and 7 columns, and we have 3 different types of panels. The first one is the one that what we call a single ADB panel, and this is because of the panel is made of PV. Then we have the double ADB panel, which has 2 different parts. In the lower part, there is a window, and in the upper part, there is aluminum cladding. And finally, the triple one, because in the upper and lower parts, there are in both aluminum cladding, while in the middle, there is a windows. We have 9 units of the single panel and 6 units of both the double and triple ones. Okay, let's go now through the renovation and the works done in the site, and especially focusing on the execution times, because this was one of the objectives of the project to reduce them. So the renovation started in March and lasted until May of this year, having a duration of less than 2 months. We have divided the whole process in 4 general steps in order to simplify it. And the first one was obviously the dismantling of the existing facade, because it was not possible to install the panels over the ventilated facade. And this has a duration of 7 working days. In the picture, you can see the process of dismantling. And then the second step, where all the preparation works for the installation of the ADB facade panels. These works were, for example, to install the anchoring system, to install the fire protector elements, to install an acoustic isolation band, or to drill the main wall in order to pass the wires of the automatic shooters, among others. All these works lasted 12 working days. And then once all the facade prepared for the installation, we did the installation of the ADB facade panels. It was very fast because it took just 6 working days, which is considering that we have 21 ADB facade panels. It is between 3 and 4 panels per day. And also, as you can see, there was no need for any type of scaffolding, and all the installation was did only with a lifting basket and a crane. Here you have the pictures. We started from the lower left corner, and the last one was the one in the upper right corner. And finally, after the installation, the last step was the dismantling of the existing windows from the interior, and then some finishing works. These works took another 7 working days, and were, among others, for example, to finish the internal frame of the windows, to sealing some joints, the completion of the electrical circuit for the automatic shooters, and to finish the lateral or the crowning of the facade from the exterior. So finally, we got the result. This is the facade that we have installed in St. Quirze. As you can see, we have 3 columns of PV, and the rest are windows, balcony ones and smaller ones. And here you have another picture. This is an aerial view of the building, and I have put this here just to show you the difference between the ventilated facade that we had at the beginning, which is the one in the left, and the new one, the Plug-n-Harvest one that we have right now. Okay. About the PV system, we have installed 33 glasses within the 9 single ADB panels that I have showed you, and the total peak power installed is 5.38 kilowatts peak. We have used an inverter of the brand Solis, and the nominal power is 6 kilowatt nominals. The system has been started up and legalized just 1 week ago. And the production is shared equally among all the dwellings, and the surplus of production, which is not consumed in the building, is injected to the grid and compensated through the electricity bills of the tenants. As I said, we don't have enough real data yet, but it is expected to reach a self-consumption ratio between 60 and 80% of the PV production, which means that between the 60 and the 80% of the production will be consumed directly in the building, and the rest, the surplus, between 20 and 40%, will be injected to the grid and compensated. The average hourly coverage is expected to be around 30%, what means that from the total consumption of the electricity consumption of the building in every hour, more or less the 30% will be produced thanks to the PV system. So to finish the presentation, I'm going to present some conclusions or some benefits of the Plug-n-Harvest solution. The first one is the significant improvement that we have in the opaque and translucent enclosures. Here in the table, you can see the values of the previous situation and the new ones for the Plug-n-Harvest solution. We have also solved some thermal bridges that which ones I have shown you before in the pathologies slide. And thanks to all of that, we expect a reduction of the heating and cooling demand around 10 and 15%. We have also incorporated PV, and thanks to that, as I have already said, we expect a 30% of reduction from the electricity consumption from the grid, and also a 30% of reduction of the non-renewable energy, primary energy in the building. Also, will be extra economic savings from surplus compensation through electricity bills. We have also been able also to shortening the renovation time. we have taken advantage of the circular economy benefits that hopefully Tony will explain now. And finally, we have done several surveys to the users in order to evaluate the degree of satisfaction. I have to say that the users are really satisfied. The level of satisfaction is very high. So our is also. So thank you very much for that. For more information, you can check all the Plug-n-Harvest project social media. You can check also the AHC Housing Agency of Catalonia web page. And to finish, we have published a study case here in Build Up portal that if you want, you can check, read, and get more information about our pilot. Thank you very much for your attention.
Thank you so much for this detailed and pertinent description of the case study and the outcomes. That is, I think, what our audience is more interested in. We go back to Tony Erena. Hope you hear us. Perhaps you don't put the camera just in case. Do whatever you feel better, and go back to understand the circular economy aspects of this design. The floor is yours. Thank you.
Okay, can you hear me now?
Yes, absolutely.
Okay, thank you very much. Sorry, sorry for what happens. I don't know if I can pass again the. It seems that yes. Okay, so this was already explained. Okay, so we will make this our back point. So our goal in this Plug-n-Harvest was to design a modular ADB solution that Neil, maybe it was fine that Neil presents the visual solution of the ADB, and then we come back to the circular economy or circular design benefits, because you already have that visual aspect of the final product that we are developing in the Plug-n-Harvest. So our main goal was to design a modular ADB solution, and to have implemented, as Jacobo says, in 6 pilots, 4 pilots and 2 pre-pilots, with the idea of a product that could be easily produced and manufactured on the fabrics, and then transport it to the place or to the site, as Neil says, in a very short time period, install it on the facade. Also using well-chosen materials, non-toxical material, recyclable material, reusable material, in order to reduce at the maximum the energy embodied in these materials, in this facade. Also, we develop an evaluation methodology for an impact assessment of circular economy solutions. We tried to assess the level of circularity that our solution had, and this evaluation methodology is not just for products but also for refurbishment or new buildings. And also we try to develop business models for each one of the demo cases, adjusting their singularities. We have to in mind that we have residential and also offices and so on. Okay, so there's big difference in this product is that usually the chain value of the actual construction sector is a linear chain value, when the people who design is not the people who build, it's not the people who use and operate, and the only relationship or the only point of contact between these people, between these stages, are just a contract in buy and sell contract, with not extended license agreements or not extended guarantees agreement, or at least very short extended guarantees. So we are changing, or we are trying to change, or we think that this sector should change to another model, a more circular model, that enhance this large terms contract in order to give more guarantees on the performance, on the maintenance, but also putting more attention in the life cycle of the product to more durable product and more usable product at the end of their life. What we are trying to do here is to have the highest residual value of our product in order to reuse, to make it attractive to reuse, to recycle, etc. Okay, so for doing that, we use the circular economy design requirements, CDR, use safe materials, thinking system circularity, preserve transparency and traceability, keep track of valuable materials, and also rethink business models and looking for new partnership models. And as I have said before, changing the chain value to the linear chain value to a circular chain value. I'm still there. Okay, so I cannot change the slide.
We see your slide.
Yeah, I want to change it, but I can't change it. If you could pass my slide, please. Okay, so we have, sorry, there is something delay in the connection, so we have passed among several slides. We are on the evaluation methodology and impact assessment of circular economy solutions. So this we have, well, now we're changing, wait a moment. Okay, so the evaluation, sorry, because it's changing a slide in a mad way. The evaluation methodology and impact assessment of circular economy solution was one of the goals of this project, and it is based on a life cycle concept. You are using all the stages of the product, not just the operational one, but every stage of the project, ensuring that you are using the best options for the product stage, but also for the operational use and the end of life stage. What this evaluation methodology tries to do is to quantify the flow, the circular flow that is included in every vector. We were using several vectors as the material vector, the water vector, the energy vector, and also the social vector. We are also including the economy in a way of LCC in order to calculate several indicators that could assess us in the level of circularity of our building. It stays okay. So what we finally had is, in this case, where we are showing the different indicators: the energy circularity indicator, the material circularity indicator, the social circularity indicator. We need to have in mind that these indicators are from different vectors and can be mixed easily in just one indicator. Okay, but the main thing here is that you use it every stage of the product in order to have a wall perspective. So this is all. I think I have missed some slide, but it's going too slow for me, so I cannot understand in which slide I am right now. So what I'm seeing now is pilot case 3.
Yes. Sorry for your connection, Tony. These things happens, but thank you so much, because in any case you brought some of the current keywords, as circularity, replicability, modularity into the discussion. So it was really interesting to listen it. See, as a
If you
full
want,
conversation.
if you can change me the slides, and
Sure.
I can. Yeah. So we
Daniel,
can go back. Yeah, we
Daniel,
can.
if you can recuperate the controls, just work them for him, please.
If we can go back to the initial, I can go through to the
14,
slide.
Daniel. Yeah.
Yeah.
There you go.
Okay.
There you go.
Advance. Well,
one
forward.
more, Danny.
One more. One more. One more.
To the front.
So we are in the circular economy aspect. No, to the front. To the front. Advance, please. Advance. 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 Forward. Okay, so the CDR, these are the circular economy design requirements. First one, we use a material database developed inside the project in order to select the best materials. When I mean the best material is not the cheaper, but the more reusable, the more safe from a health point of view, the more recycled, and the less with the less quantity of voided carbon in each material. So inside the project, we create a circular material database, and we work with the providers in order to select the best materials for this ADB solution. Go on, please. As Neil said, it was really very fast, everything, because of Aachen tried to design a facade that could be mounted and dismantled easily without problem, trying to maximize the residual value at the end of the life, in order to dismantle every layer and try to use it to recycle and to reuse without a high energy amount in order to put it on back on the cycle. Go on, please. Okay, then another aspect is to keep the track, to keep the wall track in the during all the life cycle, in order to have the maximum quantity of information. And when anybody outside of this cycle wants to have to insight in this material or in this product, they could have all the information they need to extract the materials, to repair, to maintain this product. So it is very important to have a system of traceability, a system of tracking with all the information that is possible. Go on. Yes, and then the last is the rethink business model. We thought, we developed, and we worked with a facade as a service, in which the property should not be in this model of the tenants, of their inhabitants, of the users, but they pay for this facade as business as a service in order to have the best performance for this facade, in order to have the best maintenance for this facade. So it is a new business model that that is based on long-term guarantees and long-term agreements. Go on, please. Okay, this is what I already have explained about the methodology. We have 5 vectors, including the economical one, energy, material, water, social, and the economical one. Go on. This is based on levels. This is based also in the concept of LCA, all the life cycle of the solutions. Go on, please. You can move. Okay, the product stage, the construction stage, the use stage, and the end of life. This is all the stages. This is the formulation of this indicator when the upside of the equation are all the circular flows, and the downside of the equation are all the regular flows. So we know the percentage of the flows, of the quantities of the energy that it's circular against the regular, the linear concept of the energy, materials, and water. So move on, please. Okay, so we assessed this. We applied this methodology to Sankirra, to Grevena, and all the cases. I think that it could be all from our side.
So thank you so much, Tony. And we go to the final presentation from Dr. Nikolaos Margaritis, mechanical engineer and project manager at the Center of Research and Technology ELAS, CERT.
Hello.
That is going to present us another of the pilot case, this one in Greece. Thank you so much. The floor is yours.
Yes, hello from Greece. I will. My name is Nikos Margaritis. I'm working in CERT as a research engineer, and I was technical manager for the Greek pilot located in Revena, north part of Greece. Here we have a building that is hosting offices of public sector. It's regional authorities of Western Macedonia. The floors that were selected to retrofit it was first and second. You see here the circles that these spots that we selected to renovate. These include 4 offices in total, 2 in each floor. And in the next slide, you can see how it was before how was the south facade of the building before the pilot installation. And in this photo that you now see, you can see the parts that have been renovated. Also, this is the south, but also in the next photo, you can see it better. Here is the southeast part of the building. So this part and this part was in this part were installed the ADB modules, and this is the southeast side of the building. And in the next slide, you can see here the southwest side of the building. So we have 2 symmetrical installations of this smart facade in this building, including total. So during this project, the final technical specifications were exported from us and in cooperation with other partners. Regarding the ADB facade, it includes aluminum profile designed from alumil. Finally, we selected 2 modules with these dimensions that were incorporated in the facade. We're talking about a BIPV system of amorphous silicon material, thin film. In total, we have installed 150 square meters of photovoltaic system with a total power around 8 kilowatts, which was the supplier was Onyx. It has also 4 inverters and 4 charge controllers for the system of photovoltaic, which is autonomous. It is not connected to the grid, but it is used to supply power to these offices of the building. Regarding the storage unit, it includes 24 batteries for 1 day autonomy. The supplier was Sunlight, and in the base of this system was part of insulation, 3 centimeters of stone wood insulation from Fibran, with a thermal conductivity coefficient very low according to the national regulation for energy efficient buildings. And also below of window, each window in each office, a ventilation heat recovery device was installed in order to increase the interior efficiency, the interior, let's say, ambient of the offices, and to increase energy efficiency of the total system. Here in the photo, you can see the batteries, the converters, the insulation behind the aluminum profile, the Onyx profiles, PV Onyx profiles, and the heat recovery system installed in each office. Also, here you can see some photos of the installation of the system. Renel was the company that was the contractor of this system after a tender procedure that the region of West Macedonia had launched. So the company installed the whole system around in 1 month, and checking that all systems that are working properly. The installation was ended by April 2022. The main delay of delivery was the main delay in the whole installation was the delivery of PV, the PV photovoltaic panels. So this delay caused the installation to be also delayed until April. No big problems were emerged during the renovation process, but the most important aspect was the good communication between PV panel supplier and the integrator of the whole system on site in order to achieve the optimum result. The selection of materials has been done according to the socio-economic considerations, and the users of the offices, from what I can understand, they were happy regarding the installation and the renovation of this part of the building. This photo are during the construction. Also, I have some photos here from the inverters for items of Victorenergy Multiplus, the batteries which were installed in a small room behind the offices. Also, you can see in the detail in the aluminum and the PV material, and this also photo shows that in each window a separate construction was made in order to be able to control the air in the room. So different PV panels were selected. The panels that were in front of a wall had very dark, no transparent PV panels, while the panels that were selected for to be installed in front of the windows were selected to have a medium transparency in order not to reduce the physical the light in these offices. This is again the photo of the installed system in southeast and southwest corner of the building. Also in these 4 offices were installed monitoring equipment in terms of temperature and humidity sensors, door window sensors, energy meters, smart sockets, calorimeters for energy consumption of thermal radiators, thermostatic valves, CO2 sensors, weather station, and other devices in order to monitor the efficiency of the system before and after the renovation. So you can see here the results of the signals of monitoring equipment. For example, the office temperature in the first office, or the office humidity, of carbon dioxide inside the room, and aggregate consumption in this office. The pre-monitored results were extracted from June 21 until April 22. In the end of April and 22, the total system was installed. So from May until October, until now, let's say, we are now in the post-monitoring phase. So again, we measure the same values: temperature, humidity, CO2 dioxide consumption, in order to better assess the energy situation of these offices and in general of the building before and after renovation. This measuring campaign is still in progress. In some months from now, we are going to have a better view of the benefits of this system into the building. And this also will be a step in order to realize and to understand how the building would behave if all the facade was renovated with this system. That's all for the Greek pilot. Thank you again.
Thank you so much, Nikolaos. Thank you for seeing another implementation different to the first one, and although also making an impact in the building. And now we go to Susana Presaknova, innovation architect. So the view of an architect here from Pitch Architects. She's gonna go through all the questions that have come into the system for the speakers. The floor is yours. Thank you.
Thank you very much. Hello, everyone. Also, thank you for inviting us as a consortium here. On our side, as Big Architects, we were responsible for the implementation work package since the middle of the project. So we were working very closely with the pilot implementations, and also, well, with all the partners that are here today. So I'm happy to be here to, let's say, distribute the questions, and if necessary, maybe to add something as well. So we already had some questions from the people who are watching us. Many thanks for them. The first ones, we have questions for Neil from Emily. So Neil, there are actually 4 questions. Well, let's go through the simple, short ones. The first one was whether there was a monitoring time before the implementation, and if yes, how much time did it take?
Yes. I have not presented that part because, well, I have just 10 minutes, a very short time to explain a lot of things, 4 years of project. And I have centered my presentation with the implementation, but yes, the answer is yes. We have monitoring also in St. Kirse. We have a pre-monitoring and a post-monitoring. We installed this, all the monitoring, I think it was more or less 1 year before starting the renovation. So we have 1 year of pre-monitoring data. I think I have answered the question, right? Yeah.
Yes. Yeah, thank you. Also, another short question was, in the renovation timing, was the time of production of the panels and design taken into account? So you explained well let's say how many days took each part of the process. The design and the production were not included in those days, but maybe you can explain shortly how long time did that take?
Yes. Well, this is not included, yes, in the presentation. I have just, let's say, focus it on the works done in the site, because then is what bothers the users, what you have, for example, to cross the street, or I to say and so on. So yes, but we have a schedule with all the times registered, all the manufacturing times, all the supplying times from all the providers of different materials. So we have everything, let's say, controlled, and I don't have all the times in mind right now, but of course this, I think, well, I'm not in charge of the, for example, the KPI performance indicator calculation, but all of these times are for sure taken into account when calculating all the indicators and so on. So yes, we are considering this in our deliverables and our conclusions.
Mm-hmm. If I remember correctly, the production of the panels took something like 2 weeks, so it was also very fast.
Yeah, it was fast.
Yeah, was all the let's say organizing around, right? Like getting the materials, the supplies. There were some problems also on the way, so we had to replace the profiles because the first try didn't come out well, and so on. So this was maybe what took long.
Just to jump in also. Yes? Sorry, I mean, we have also to consider and keep in mind and note that these things, this let's say process, this entire supply chain was actually let's say used and activated during COVID, right? So it's, I mean, it was not a normal case in the end. But yeah, I mean, just to complement the others as well. So it was during that time, it was COVID, you know, physical meetings were difficult. I don't know, companies were struggling to cope, to get back from the COVID, let's say, lockdown. So it was a little bit, it was a mess actually in the market.
Yeah, we had very tricky situation between COVID, Brexit, and other global events.
Brexit also for Wales, yes.
Yeah, the UK project that we don't present today, but also we have UK pilots. Okay, so then there is another question for Neil, but I think we can also extend it to Nicolaus, so maybe both of you can respond to that. And that is like, what were the main challenges that you found in the installation? We can add like of this prefabricated modular, very technological system. So Neil and maybe Nicolaus then.
Nicolaus, if you want to start, please. Or
the main challenge, I think, was the I mentioned it in my presentation, the good communication, because a lot of people were involved in this procedure, the manufacturer, the people that the integrator, the different suppliers of the different equipment inside the system. So all these systems have to be totally harmonized, let's say, in order to have the optimum result. So not all the times was easy, this part of communication, but in the end we had the desirable, let's say, result.
Yeah, well, it has already been said, and I don't want to repeat, but the biggest challenge is that we found ourselves in the middle of the COVID, what complicated everything a little bit more. Then there were other worries, like, for example, that we are working with innovation. This is the first time that we're doing something like this, even though it is pretty studied and tested and everything, and that then there are always, I don't know, worries or things that can worry you. Well, more or less that, I don't know, the installation process was good, quite good, and well, it's that.
Thank you. Okay. Then before we have also some questions for Tony here, but there is still one for the pilot implementation, and I think also well, Neil, Nicolas, or also Jakobos, you can respond to this. So the Emily comments that we have seen 2 examples in warm climate. Is there a difference in the implementation in colder climates is one of the questions, and then she's also asking if there has been done any study of building typologies linked to the replicability. So how is actually our proposal replicable, and also considering the cold climate. Maybe, Jakobos, you can start.
Yes. So I mean, yes. So we had 2 other pilots. One was in Wales, in Cardiff, which was a residential one, single-family houses there, not high-rise buildings. And the other one was in Aachen, Germany, which was a tertiary building, a tertiary case. What changed there is more, I mean, for the German case, for the Aachen case, it was I mean, both were special, but let's say the particularity in Germany was that the deployment of the ADB was on a balcony. So there was particular, let's say, measures that had to be taken about, fire escaping, routing people, and stuff like that, because the facade itself was installed on the balcony. Of course, the configuration of the facade, like the technologies or the insulation used, was different than Greece or Spain. For the wealth case, it was mostly about let's say architectural shapes. So we try to follow the outline of the facade in that building. So it was, if you follow the social media and if you check our website, you will find out that these single family house buildings have a triangular, let's say, roof. I mean, a triangular shape, the top level of the facade. So the facade that was the ADB installed, but tried to follow also the geometry, let's say. So it's a geometrical mostly problem in Wales, and of course, I mean, it was also differently configured from Germany. So they used both. The Welsh case used a lot more, let's say, insulation rather than the German one. The German one used, for example, heat recovery systems, which was easier to install. The Welsh didn't. Yeah, I guess I don't know if
just to add here that even though the Greek pilot is in Greece, Greece is connected with summer and good weather. The specific pilot in Renovations in north part of Greece, and they faces very heavy winter. So we're talking some days may have -10 or -15. So it's a case also of cold climate.
Mm-hmm. Thank you. Neil, would you like to add something in regard to the replica?
It has pretty well explained it. Thank you.
Perfect. Okay, so let's pass to the questions for Tony. You were talking about easy disassembly. Are you working with dry joints even in the connections with the building? Is the question. So how the panels were actually connected to the building? Maybe I can also comment on that. We were working on this with the producer of the facade panels of the final solution. And yeah, there is like everything can be actually feasibly dismantled, both from the panel itself and the panel from the facade. Also, let's say the connections within the profiles, to connect the specific elements. They were designed particularly as new part of these profiles from the provider in order to allow this easy disassembly. And there are some parts which had to be done more, let's say, in a wet way to assure the fire and acoustic performance. But these are minor elements. Maybe Tony, you can continue on that, how that was considered in the evaluation of the circularity.
I think that's enough. Well, just saying that we have some KPIs regarding this assembly, and all that question regarding this KPI was answered by the not only by but the producers, because we have different manufacturers here. We have on one side. The idea is that this solution is not just linked to one manufacturer, but that it could be used for any manufacturer that wanted to apply this solution, and both manufacturers and then also the other installer answered this assembly KPI always in terms of theoretical in a theoretical way, because only one pilot has this assembly its own design, but the others are still there, and the idea is that they stay there for a long time. But everyone answered it very in a very positive way to these questions. So if finally the idea is that the design will allow an easy disassembly and easy and not affecting the building, but the fact is that at the moment it's just a design, because all the panels are still there, and it will be the idea is to keep there as long as we can.
There is a continuation of the question. Is it also an indicator not to damage the building, so it can be easily used in heritage? Well, I mean, there are always the anchors, right? So you have to kind of somehow connect the panels to the existing building. So there are what you could call like little interventions. I wouldn't call it damage. I don't know if you all agree, but well, if there is a chemical anchor, which is generally the case, so then there is, let's say, some kind of impact that will stay there, but it's not a large impact. The problem of the cultural heritage is generally that you can't really touch the facade from the exterior. So in that sense, we wouldn't be probably allowed to use the Plug-n-Harvest solution, because it would be from the exterior, because the idea here is not to disrupt the users. So we approach just from the exterior till the very last moment, where the let's say the windows have to be dismantled. So I would not say it's exactly the case, but maybe someone else wants to add something to it. Okay, I'm checking if we have some other, for Nikos, another question. Nikos, are there any technical spaces needed inside the building for the control of the system?
No other technical, it's only the offices, but near each office, it's a small, let's say, room. It's not a room, it's a very small space that there the batteries and the inverters are located, because this can be incorporated in the facade. So these are near the system, but in a separate space, small space near the office.
Just to jump in also, I mean, internally, aside from the batteries, which is the normal, the inverters, the electrical part, let's say, of the facade, we have also, as already mentioned, the automation part. So it's not only about the ADB, it's about the intangible things that exploit the ADB capacity. So we have appropriately, let's say, how to call it, smart renovated, or let's say we have installed appropriate sensors and actuators to control the thermal loads, smart plugs, wireless sensors. We focus mostly on Z-Wave technologies on this matter in order to be able to control eventually the energy consumption and the thermal loads of the building at the different, let's say, offices, at an office level.
Yes, so the sensors are located inside the room, the office.
So, well, I think these were the questions that we received. we could be talking more, but I think we are already 1:15, so probably this is our deadline. What do the organizers say?
You have a space if you need it. If there is something more to say, please proceed.
Well, maybe if anybody wants to make some concluding remark.
Well, the conclusion is that just to take the floor and conclude. I mean, again, I would like to thank everybody for being here. I would also like to thank my colleagues, Susanna, Tony, Nikos, and Neil, for supporting the presentation and let's say providing insights about the pilots. I would like to thank once more Build Up and all of you, the attendees, that showed interest in our developments, and please feel free to follow up the final results of the project, the conclusions, the KPIs calculation, which are currently, let's say, being finalized through our social media and through our website as well. So thank you all, and thank you to Build Up for making this happen, let's say.
Thank you very much. And just to conclude from our side, it was an honor to host you today. Very interesting project. And to our audience, to know that we will be in YouTube. So you will have all the webinar there. Plus, we will include the slides in the attachment. So you will have all the information about all the speakers plus the project itself. Thank you so much. Until the next one.
Thank you.
Thank you all. Thank you.
Thank
Bye.
you.
Bye-bye.
Thank you very much.
Bye.
Bye.